Hi, my name is Tom Tim. I'm an undergrad junior majoring in artificial intelligence at Carnegie Mellon. I'm here to present my solution for this XR LT challenge, ChexFusion, which scored first place in both validation and testing. So, to present some challenges in chest X-ray classification, or any kind of medical data in general. One problem is that we are often given long-tail distribution of classes. Another problem is we often face multi-label settings, and where there's multiple labels for a single data type. And one more problem that I identified was that we're given multiple views or multiple modalities for a single patient. And these are the three main challenges that I identified in this particular challenge and medical data in general. So the key contributions of this paper tries to address each of these three challenges separately. And one contribution is the proposed ChexFusion, transformer-based fusion model for integrating multiple views. And we also verified the advantages of data balancing and self-training techniques. And the solutions for first place performance in both validation and testing. So ChexFusion consists of two stages. The first stage, we try to pre-train the backbone, which will be used in stage 2 for image fusing. And in stage 1, we try to train a general feature extractor for all sorts of views. And naturally, we trained on all type of views. And one key contribution in the stage 1 pre-training was that we employed a transformer-based classification called ML decoder. And this is different from the generally used global averaging tool. And it's more specialized for multi-label settings because it attends to different features based on the class array that we're trying to classify. And stage 2 of ChexFusion is really where the fusion of the images happens. And the main idea in ChexFusion is that we first encode each images with the pre-trained backbones in stage 1. And after that, we try to consider each image as a sentence of features and encode it with a transformer encoder. So the stage 2 of ChexFusion is in architecture very similar to a text-to-text decoder transformer. And the idea is that each image is considered as a sentence of image features. And we are decoding based on the class queries that we have. So yeah, ChexFusion is very similar to a text-to-text encoder decoder that we heard. So ChexFusion was an example of addressing multiple view problems existing in medical images. But there are also questions about how we address multiple labels and long-tail distributions. So one problem that we addressed was data imbalance, and we identified two types of data imbalance in this setting. And the first is interclass imbalance, which is mainly caused from the long-tail distribution of the classes. And a solution for this was to use a weighted binary cross-entropy loss, where the weights are determined by the ratio of the class. And the second problem is interclass imbalance, caused from multi-label classification. And namely, this is the interclass imbalance means we have more negative labels than positive labels because we're dealing with multi-label classification. And to mitigate this, we use ASL loss, which is a variant of focal loss. And we identified that combining the two, using weighted ASL loss, resulted in best results. And this shows that we have to identify both interclass and interclass imbalance when considering multi-label and long-tail data. So finally, we use noisy student self-training. In this challenge, we were allowed to use external data besides the provided dataset. And we use noisy student, which is a method of using teacher models to create pseudo-labels and retraining the student model based on that. And one important observation was to use soft pseudo-labels instead of hard pseudo-labels. because of naturally we have label imbalance, and there's going to be a lot of incorrect label propagation. So soft pseudo labels were naturally the better choice. And some experimental results. A natural idea for fusing multiple views is to take a naive average of single view models trained on each image. And we showed that even naive averaging helps compared to a single view model. And expanding further from this results, we thought about tuning the weights for each of the models to improve the score. So when I say tuning the weights, often we are given with side images of a chest X-ray or a frontal image of a chest X-ray, and giving higher scores to the frontal image showed better results, which matches clinical results like doctors diagnosing more based on frontal views instead of lateral views. So it means that a sophisticated way of using multiple views is essential for a better score. And that was really the inspiration for this paper, where we tried to use transformers for a more sophisticated way of using, and it showed drastic performance increase compared to naive-based models. And these are some ablation studies where we verified that each of the methods presented in the previous slides each contributed to performance increase. And to wrap up, using multiple views in medical images help, and ChexFusion or sophisticated methods like ChexFusion helps even more. And weighted ASO loss plus noisy student further improves score by addressing multi-label and long-tailed settings. And we show state-of-the-art results for long-tailed chest X-ray classification. And here are some citations. And thank you for listening to my presentation.